The thermal physics is one of the important topics. Why it is important is not for its content, the amount of time you spend on this topic and the amount of marks you gain in any kind of competitive exams with respect to 11th and 12th class. So you have calorimetry, thermal expansions, uh, thermal transfer of heat, radiation, conduction, convection, and then you have thermodynamics, kinetic theory of gases. These topics can be easily learned in 2 or 3 weeks if you focus carefully. And then, but the amount of marks you get are generally high for the amount of time you spend.
Okay.
That is why this topic, and that way it is more beneficial also. And the questions will be very clear, clear in the sense, the less confusing, less thought provoking.
Okay.
It is more dependent on the knowing of the formula, knowing of the way to do it, and doing the problem. That's it. Very less controversial. Controversial in the sense that students will get a number of thoughts. If this rod is hitting this one, is this ideal case or is it real case? Like in mechanics, you will have a lot of situations.
Yes, sir.
Fully is given, you suddenly start thinking. If student is not so clear in practice and all, she start thinking, it has friction or not? He didn't mention friction here. If it has, so it should rotate. If it does not have friction, it should not rotate. So student will have both the formulas in their minds.
Yes, sir.
So either they directly solve the formula if they are very clear with it. If they don't know even a bit of information, they will be in confusion.
Yes, sir.
Which formula to apply there? Is it rotation formula? Is it a simple direct Newton's laws of motion formula? So they'll try to use whatever the formula they know, like n is equal to mg. They use. Is n is equal to mg always right? No.
No.
You need to draw the free body diagram. Then friction is equal to mu n. Is friction is equal to mu n always right? No, it depends upon normal reaction. Is normal reaction always mg? No.
No.
Is friction always mu n? No. Static friction again varies from 0 to mu n.
Yes, sir.
It is dependent on the situation there. If it is tendency to slip is there, is different. If it is slipping, it is different. So you see, you cannot directly draw a mu into n. Friction is there, I will draw the formula mu into n and I will get the formula done. So in mechanics, you will have these doubts. Student will know formulas, will by heart formulas, many of the students, to different situations, but will still will falter at the situation if they're not completely clear with all the in and outs in different topics. When it comes to thermal physics, okay, this situation is there. This is the formula. This is the case. You solve it, you get it answer. Very rarely you will get a tricky question where you need to use 2 or 3 fine points which you don't know. Very rarely. Either calculation might be big. If it is tough, calculation might be big, but not the understanding of the question and solving of the question. Are you getting what I want to say?
Yes, sir.
That is why it is a crucial in terms of preparation of any student preparing for 11th and 12th. So now, so if in thermal physics, we'll study in different topics like calorimetry, then initial introduction part of heat, calorimetry, then thermometer and thermometer principle, and calorimetry, then expansion, thermal expansions,
KTG.
Transfer of heat, that is how heat is transferred, the radiation, convection, conduction process, different types of heat transfer, radiation, conduction, you might have studied convection. Then we'll study about in this conduction has a lot of generally problems related to our examination. Radiation, conduction and radiation. So then you have KTG, then you have thermodynamics. These are subtopics you can divide. But one thing is, at least for this year, in this pandemic year, for CBSE syllabus, this they deleted, transfer of heat.
Okay.
They deleted for CBSE syllabus. I don't know for mains this deleted or not as of now. Generally, if CBSE they deleted, mostly it will be a relief for you. Relief in the sense, just you don't need to study about all those things.
Yes, sir.
Okay. But still we will see if it is given in syllabus, finally if they release the sheet, then I'll try to teach you this also. Otherwise, at least for this year, this I will not teach. Like that, some topics are deleted. Polarization is deleted.
Yes, sir. That comes in ray optics.
So like that, a lot of some subtopics are deleted. Whereas some topics deleted does not have any connection because you have to know those to solve the other things.
Yes, sir.
But here it does not require here in this topic transfer of heat. So in case if it is deleted CBSE, then we will keep it in the hold. We will not focus much into it. Okay. I'll keep a separate lecture on it. I'll try to record a separate lecture on them. If they are there, then you can prepare. Otherwise, no need to prepare. Now, first understand what is heat. What do you have an idea when the word heat comes to your picture?
Heat is something, a temperature.
No, it is actually energy. It is a form of actually energy. Temperature is actually the measure
Measure of heat.
of hotness or coldness. It's not heat. Okay. Temperature might give you information about the direction of heat flow. Net direction of heat flow, not direction of heat flow. So heat is energy. The amount of energy transferred from, or the amount of energy transferred from energy transferred from one system to or other system or one object to other object due to temperature difference. Here is the catch. In non-mechanical manner, non-mechanical transfer of heat is energy is called as heat. Mechanical also you're doing right work. Work is a
Yes,
form of transfer of energy. Do you remember that?
yes, sir.
But there, the work is a work done is a mechanical transfer of energy. That means you use something like motor, mechanical equipment. Use motor to pump water. You're doing motor, right? That's a mechanical
Yes, sir.
equipment. Or otherwise, when you take a block from the ground and keep it on the table, you're using your hand. So these are all mechanical work done. So mechanical transfer of energy, if you're doing, if you throw a ball, again you're transferring energy. That is mechanical work. So mechanical, that is also work done. So mechanical transfer of energy is work done. Non-mechanical, that means just due to temperature difference. You are not using any machine and all here. So temperature difference will cause actually the transfer of heat. This transfer of energy, suppose you keep a cup of tea on the table and suddenly the heat transfer happens from tea to surroundings. Are you doing any mechanical work there?
No,
Using some machine or something?
no.
So here the work done is actually transfer is happening, but due to temperature difference, not due to any mechanical
Yes, sir. I
effort.
must.
So mechanical effort transfer of energy is called as work, but whereas non-mechanical transfer of heat due to temperature difference is called as heat. That is also energy.
Okay.
Okay. Then coming to, if you get clarity about the heat, what is a calorie? Calorie is actually used to describe energy heat, but they both are relevant because here also work is also unit of work is also a in transfer of energy. Heat also is transfer of energy. That means they both units can be related.
Okay. Understood.
Because there are both are energies. Here calorie is one of the unit used describing the amount of energy, heat energy transferred. Okay. So,
Yes.
what is the definition of calorie? Because sometimes very simple, trivial concept, definition-wise bits can also be asked in competitive exams. That like to like bits and medical entrance examinations. Okay. Calorie is the amount of heat required to increase the is the heat required to increase the temperature of 1 gram of water at 1 atmospheric pressure from every 14.5 to 15.5. These things you need to remember. 14.5 to 15.5 at 1 atmospheric pressure, 1 gram of water. That means calorie is defined like this. For suppose 1 gram of water is there in your hand at 1 atmospheric pressure, and if the temperature is 14.5 degrees of the water, given water, and if you have to raise the temperature of water of 1 gram of water at 1 atmospheric pressure from 14.5 to 15.5, you should give some energy right to it.
Yes, sir.
That energy is called defined as one calorie. Many people suddenly, many students will study in this way. Heat required to increase the temperature of 1 gram of water by 1 degree temperature rise. That is 1 degree only, but from where to where? 14.5 to 15.5. In general problem solving, you will take it. But that is, whether it is 17 or 18, you will take it as 1 calorie only and solve. But exact definition, if you go by the physics point of view, so these values are also important. Okay. In general, if you have to calculate from 17 to 18 also, at 1 atmosphere, you will use calorie only. Got it? What I want to say?
Yes, sir.
But definition wise, exactly it is equivalent to rising 1 degree from 14.5 to 15.5. 1 gram.
Yes, sir. Understood.
Then mechanical equivalent of heat. What is mechanical equivalent of heat? That means here both are energy related, right?
Yes, sir.
Mechanical work also energy transfer, and heat also energy transfer. Can we relate both of them by using some concept, that is mechanical equivalent of heat? That is 4.2 joules of work should be done to get 1 calorie of heat. Are you getting this?
Yes, sir.
That means if agar 4.2 joules of work is equivalent, that means 4.2 joules of work, if you do, that means that if you convert that mechanical work into heat energy, if you convert,
Okay.
how many calories of heat it will give? 1 calorie of heat.
Yes, sir.
1 calorie of heat transfer. Okay. So this can be written as 1 calorie is equal to 4.2 joules, right?
Yes, sir.
This W by Q is called as this is actually here, this 1 calorie by 1 joule is there, right?
Yes, sir.
4.25. This 4.25 is called as a mechanical equivalent.
Okay.
So now this does not have any units because 1 calorie is also in an energy, 1 joule is also in an energy. So energy by energy dimensions will be dimensionless, right?
Yes, sir.
So one of the HC Verma question is also asked based on this. This is what are the units of mechanical equivalent of energy? No units.
Understood.
That is the ratio of two energies. Okay. Shall we go?
Yes, sir.
Now we will study in some situations how much energy is given to this much substance to raise this by this much temperature and all. we'll try to relate those kind of questions with the concept now we'll study. Okay, first, suppose if you have like 5 gram of mass, 5 kg of mass, or otherwise 10 gram of mass. Any water, suppose example I'm taking water. That means if you want to raise the both substances, this also water, that is also water, this is also this is 5 grams, that is 10 grams, this also should be raised by 2 degrees, this also raised to by 2 degrees temperature. So for which, what is energy comparison, which will require more energy?
5 and 10 masses. Of course, 10 grams will require more.
The amount of heat is proportional to raise the temperature is proportional to mass of the substance, right?
Yes, sir.
Okay. Now I took two situations, 5 grams, 5 grams. Well, actual derivation, how they derived is different. Just to make you understand, I'm trying to relate these things. Okay.
Okay.
So 5 grams is 5 grams is there. It's not that everywhere you can derive the formula like this. Okay.
Yes, sir.
So 5 grams and 5 grams is there. So if you want to raise the this by 5 degrees, this by 10 degrees, for which energy is more required?
That 5 gram and 10 degrees only will require more
Okay.
energy.
That means the 2 is proportional to temperature difference, right?
Yes, sir.
So that means Q is directly proportional to mass into delta theta, can I write?
Yes, sir.
If Q is equal to, if you apply some constant.
Okay, into delta.
No, this is nothing but that Q is equal to M into S into delta theta, this constant. This S is
Okay.
called as,
I wanted to derive this thing.
huh?
I know this one, sir, but I didn't think that you're going to derive this one.
Okay. Specific heat of the substance. You know this formula. You have applied number of times.
Yeah.
Chemistry or physics?
Physics only, sir. Chemistry also I applied this many times.
Okay. Q is equal to ms delta theta, where is S is the specific heat of the substance. This S depends upon the properties of the body, whether it is solid, liquid, whatever the situation. Okay, the specific heat, properties of the substance, and the temperature it has. But generally, in most of our problems, we'll consider S is not changing with respect to the particular temperature. Okay.
Yes, sir.
In most of our problems, but in reality, that S will depend on temperature.
Yes, sir.
Now this S can be written as definition of Q is S is equal to M by Q by M delta theta. This definition can be solved here in thermodynamics or thermal physics. Number of definitions will be there of this sort. Or in physics also you can write. Now S can be defined as specific heat capacity, can be defined as the amount of heat required to suppose this mass is equal to 1 gram I took, okay. This delta theta is equal to 1 degree I took, okay.
Yes, sir.
Can I say that S is equal to Q then?
Yeah.
That is nothing but what? The amount of energy. Specific heat is defined as the amount of energy or amount of heat. The amount of heat energy required to raise the temperature of 1 gram of substance by 1 degree is called as specific heat. Got it?
Yes, sir.
Keep M1 delta theta 1, then S is equal to Q, right? Q
Yes, sir.
that is amount of energy or heat energy required to raise the temperature of 1 gram of substance by 1 degree is called as specific. Okay.
Yes, sir.
Then we'll actually in exam I'll give specific heats of some standard values.
Okay, sir.
In exam, mostly that values will be given to in joules also. So the specific heat of water is, we'll take, we know that is 14.5 to 15.5, but for all the 0 to 100 degrees, we'll take this 1 calorie only. 1
Yes, sir.
calorie by gram degree centigrade is equal to 4.2 joule by gram degree centigrade is equal to 4.2 kilojoules by kg degree centigrade. Otherwise, 4,200 joules per kg degree centigrade. Specific heat of water. Specific heat of ice is equal to half calorie by gram degree Celsius, 4.2 by 2. That is 2.1. Just I am trying to relate joule per gram degree Celsius. That is equal to 4.2 by 2 kilojoule per kg degree Celsius. That is equal to 4200 by 2 joule per kg degree Celsius. Like that specific heat of steam. In exam directly they'll give 4186, like that they will give. Okay.
Yes, sir.
Well, I'm taking approximately 4200, but in exam if they give you 4186 joules, then you need to take that value and solve the problem.
Yes, sir.
4.186 joules, otherwise 4.186 kilojoules, like that they'll give. So the heat of steam is 0.47 calorie per gram degree Celsius. That is equal to 0.47 into 4.2 joule per gram degree Celsius. That is equal to 0.47 into 4.2 kilojoule per kg degree Celsius. Are you getting how I am writing?
Yes, sir.
So these are the values. You can make note of them. Then suppose there are molecules of water. Okay, suppose water or any substance. So it has some energy, right? Internal energy.
Yes, sir.
Now when you give heat energy to it, it will have two parts of energy. One is kinetic energy, I'm taking, one other is
Potential energy.
okay. When you are increasing the temperature, this we will study in kinetic theory of gases also future. When you are increasing the temperature and kinetic energy are related. Temperature and
Kinetic energy are related.
so state and potential energy are related, because potential energy will depend upon the position, right? Position of the particles. Suppose if
Yes, sir.
two particles are there, what is the potential energy? K G m1 m2 by r. That means depends upon the separation between the two particles, right?
Yes, sir.
If you take two charged particles, positive K q1 q2 by r, right? That is the formula. So it is again dependent on the uh, position. In solid state, there will be one kind of packing of the system, and there's liquid state, one kind of separation between the molecules, and in gaseous state, there is another kind of separation, right? So potential energy is more related to the state of the substance.
Okay.
Kinetic energy is related to the temperature of the substance. Kinetic energy, if the temperature is of the substance is very high, the kinetic energies of molecules will be very high.
Yes,
So
sir.
if there is a change in kinetic energy, means there is a change in temperature. If the change in potential energy, means there is a change in state. Got it?
Yes, sir.
Now, suppose there is a solid state is there, solid substance. If you are giving Q energy to it, so now if this solid state is continuously changing, for suppose, first thing what will happen, suppose I'm taking an example of minus 20 degrees ice, I'm taking. Is it solid or not?
Yes, sir.
If you're continuously giving energy, what will happen to this is, this solid's temperature will raise. What will happen?
Temperature will rise.
Because you're giving heat energy, that energy
Yes,
is
sir.
given as, what is this? Will the phase change there? No.
No.
There will not be any phase change, but there will be a change in kinetic energy. That means potential energy will be constant. State will not be changing, but there will be kinetic energy will be increasing due to that energy. So slowly what will happen? Temperature will be
Increasing.
to minus 20, minus 19, minus 18, minus 17, minus 16, minus 15. Like that, it keeps on coming to one state that is called as solid. That is 0 degrees ice. It's called this point also, that is melting point. When it reaches
Yes.
the melting point, what will happen there? So that particle has reached a saturated state of kinetic energy now. What will happen is, whatever the energy you're supplying, now continuously you are supplying energy, right?
Yes, sir.
That energy will be at that time, kinetic energy will be constant. That means temperature will be constant. Very carefully remember this point. Temperature will not rise there, but their potential energy will rise, keep on. There will be change in potential energy. So what will happen? This solid will be converted into, here temperature will not be changing. So what will happen? 0 degrees water, it will get converted into liquid. Still if you are giving heat now in this state also. Then whatever, in this process, very careful. In this process, there will not be change in any temperature rise.
Yes, sir.
So that is why if you keep a ice and water together, and if you continuously supplying heat, then the water temperature will not rise till
But
the
the
ice gets
ice
converted
melts.
into water.
Yes, sir.
Are you getting this? So you cannot
Yes.
say so that water also keeps rising temperature, that ice also gets melted. No, both will not happen. First ice, and because they're together, right? So first ice will keep on, that's why water will be very cold. Even if ice gets converted there, when you keep the ice water outside, ice gets converted into water, but water will be still cold, right?
Yes, sir.
Will the water temperature rise? No.
Understood.
What will happen in ideal case? So slowly that first ice gets converted into water, then
Water.
water starts raising its temperature. First, the phase change will occur completely.
Okay.
During that phase, the entire substance temperature will not change. At the time, only potential energy changes, kinetic energy will not change.
Yes, sir.
Then 0 degrees water it will reach. So then what will happen? Whatever the heat, still if you are giving energy to it, what will happen? Now potential energy will remain constant. Kinetic energy will keep on.
Understood, sir.
At the time, temperature will keep on rising. It will go to 100 degrees water. Liquid, it is also liquid. Now what happens? Here it reaches a saturation point. Here kinetic energy is equal to constant. That means 100 degrees will remain 100 degrees only. And it gets converted into 100 degrees vapor. Got it?
Yes, sir.
The gaseous phase. It will go to gaseous phase. First 100 degrees. So in this process, what will happen? Kinetic energy is constant, potential energy change happens.
Yes, sir.
So this way, when phase change occurs, their kinetic energy is remaining constant, so temperature remains constant. Whatever that happens, that whatever the energy you give or take will actually result in the change of phase.
Yes, sir.
So then, but you tell me, calculate, and we know that when there is a temperature change, rise or decrease, we have a formula that Q energy required is equal to mass of the substance into specific heat of the substance into delta theta, right?
Delta theta. Yes, sir.
But here when there is phase changing, what is the temperature change?
Temperature. It was 100 degrees only, no, sir, from the
So
start.
then if you apply this formula, Q is equal to M into S into 0, so answer will be 0. But is it that
Okay.
it does not require energy at all?
It requires, no, sir.
Here this 100 degrees vapor conversion point is also called as boiling point, right?
Yes, sir. Understood.
Then you see at that time it requires energy, but we cannot calculate that energy by ms delta theta. This can only be calculated when there is change in temperature. But when there is no change in temperature, we will use the concept of phase change happens when latent heat of vaporization,
Yes, sir. Understood.
latent heat of fusion, latent heat of vaporization. Like that, there will be terms. When it is converting from water to vapor or vapor to water, we use this latent heat of vaporization. And when it is converted into ice to water or by water to ice, but the solid to liquid and liquid to solid, when we'll use latent heat of fusion. Okay.
Yes, sir.
That is Q. That Q is proportional to mass of the substance. That Q is equal to mass of the substance into that constant is L. This L is latent heat. When phase change occurs, the formula that should be used is latent heat. Okay.
Yes, sir.
So latent heat, there will be two phases. Latent heat of ice to water will be 80 calorie per gram. In exam generally, these years he is giving the values. But just I am trying to ensure if very standard things are given, you need to know those values also. Latent heat of water to vapor. Steam, water to steam is equal to 540 calorie per gram. Okay. That means it is nothing but, suppose what is latent heat? If you keep M is equal to 1 gram, you will get L is the amount of energy required to change the phase from one point to another point. Got it?
Yes, sir.
So that means you can write like this. Suppose I'm taking 1 gram of ice is there. For that, if I want to convert into 1 gram of water, I need to give 80 calories. Got it?
Yes, sir.
For 1 gram. Suppose if I have to convert 1 gram of water to 1 gram of ice, so that I have to take 80 calories of energy from it. Got it?
Can you repeat the statement once again, sir?
Here 1 gram of ice, if it has to be converted into 1 gram of water, you need to give 80 calories.
Okay.
That is latent heat of fusion.
Yes,
But if
sir.
that 1 gram of water should be converted into 1 gram of ice, it has to give you 80 calories. It will give you out 80 calories. It will give and it can convert it into 1 gram of ice.
Okay. Yes, sir. Understood.
Like that 1 gram of water, if it has to convert it into 1 gram of steam, you need to give 540 calories. But if the same 1 gram of steam is converted into 1 gram of water, it will give you out 540 calories. Okay.
Yes, sir.
So there is a kind of heating curve here. Number of times in exams also this is asked in mains and NEET exam, medical examinations, and various entrance examinations. So left side is temperature is given. Here Q is given, amount of heating. Sometimes in advanced exam and all, or mains exam, instead of Q, there is given as time also here. Why time is given is, he has already given you, this constant heat is, rate of heat is given to the system.
Yes, sir.
There's a constant rate of heat is given to the system means, so the time is, it is proportional to time, right? Energy.
Yes, sir.
Suppose if I'm giving 50 joules per 50 calories per minute, that means if 5 minutes, what will happen? 250 calories will be given, right?
Yes, sir.
Instead of Q, the graph can also be written as T and there will not be any variation. That means how the shape will be there, that shape will not change. Because with time, Q is also increasing, right?
Yes, sir.
So the graph will remain even if time is given. You don't need to get confused. In exams, time is given instead of Q. I am drawing for Q.
Understood, sir.
Because with constant heat is applied means with change in time, heat also will raise. So here the graph is initial, temperature initial. So from there, if you keep on supplying heat, what will happen? The temperature will raise, right?
Yes, sir.
There will be constant, there's a slope here. Then what happens? there you will reach a melting point, right? At that time, will there be any change in temperature? No, right? Even if you keep on giving heat, the temperature will remain constant, right?
Yes, sir.
Then after you will reach the saturation point here. From here, what will happen? Again, the temperature rises, right? Like
Yes, sir.
here, ice is got the raising temperature. Then, for example, for water I'm taking ice to here you will reach 0 degrees. This is minus something. When it reaches the 0 degrees, it will change the state to water here. So then, when you're giving continuously heat, then water will be converted into what? Water's temperature will rise, right?
Yes, sir.
You will reach a point where it is called as boiling point, TB. Then what happens? Again, water also gets converted into steam here. Then what happens? Again, steam, when it completely gets converted into steam, again temperature will rise. Are you getting this?
Yes, sir.
This curve will be there. Now here, some of the years on this also some basics are given. So here there will be a slope, right? When there is temperature changing here and here.
Yes, sir.
This is beta. I'm considering this is gamma. This is alpha. Slope of that line. What we know? Q is equal to ms delta theta, right?
Yes, sir.
Then delta theta is equal to Q by ms, right? So delta theta is nothing but y-axis here. Q is nothing but x-axis here. So y is equal to, if you compare this with y is equal to mx graph, this what is slope here?
Q, sir.
No, slope is nothing but 1 by ms, right?
Yes, sir.
If you consider mass is fixed here, the slope is inversely proportional to specific heat, right?
Yes, sir.
If specific here, if the comparison is given, so if it is given tan alpha greater than tan beta greater than tan gamma, then specific heat of this third phase will be
Very greater than
less than, so specific heat of second less than specific heat of third. Got it?
gamma is okay. Okay. Ah, yes, sir. Understand.
That kind of phases are there. Okay.
Yes, sir.
Specific heat. That means if you comparison with water, this is specific heat of steam, specific heat of water, specific heat of ice.
Yes, sir.
That means if tan alpha is equal to 1 by specific heat of solid, tan beta is equal to 1 by specific heat of liquid, tan gamma is equal to 1 by specific heat of gas. Got it?
Yes, sir.
And this is also need to take care of. This length is there, right?
Yes, sir.
Which one? This length. Okay. I'll write it. This
Understood,
is proportional to latent heat. If latent heat is a Q is equal to ml, right?
Yes, sir.
Then m is given for a given substance, m is fixed. That is Q is proportional to length, right?
Length.
That means if
Yes,
more
sir.
heat is getting taken from here to here, if the more the length is, the more the Q is and the more latent heat is. Suppose if this length is 2 centimeters, this length is 4 centimeters. So this latent heat is greater than this latent heat. That's what I want to convey.
Yes, sir.
Latent heat for this phase change is greater than this second one is greater than first one. So the slope will give you information about specific heat, and the length of the that line will give you information about latent heat. Are you getting this?
Yes, sir.
Length will give you information about latent heat. Okay. So here the concept of this topic will be mostly completed. Then we'll solve some problems in the next class.